Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. Now I'm going to explain about classification of optical fiber. Right? So in previous video I explained about introduction to optical fibers mhm, and the propagation of optical fiber, right? So propagation of light in optical fiber, right? So in previous video I explained about numerical aperture and acceptance angle. So numerical aperture is nothing but light gathering capacity of the given fiber. Acceptance angle also nothing but so maximum angle of incidence. The total below that the total interreflection will not be happen, right? So these are all explained in previous video. In this video, I am going to explain about so classification of optical fibers. Okay, so optical fibers are classified into three bases. First one is based on material. Second one is based on propagation. Third one is based on refractive index profile. Okay, so look at this flow chart. So optical fiber is classified into three different classifications. First one is based on materials. Okay, so based on materials, optical fiber can be classified into two different types: glass fiber and plastic fiber. Right? Okay. So based on mode of propagation, it has to classified into two different types: a single mode fiber and a multi-mode fiber. So based on refractive index, it again classified into two different types: the step index fiber and the grade index fiber. Right? So it has six types of optical fiber. Right? So first of all, based on material. Okay. So based on material, so which material we have to use in the manufacture of fiber. Okay. So we have two different types of fiber, right? Glass fiber and plastic fiber, right? So glass optical fiber, the core and the cladding is made up of silica and silica glasses and metal oxides. Okay, right? For example, so let us consider the core will be manufactured by um, germanium oxide and silicon dioxide composites. Okay, so now the cladding will be the silicon dioxide. Okay, so in suppose the core will be silicon dioxide means the cladding is P2O3 and silicon dioxide mixes. Okay, because the core and the refractive index will be maximum compared to cladding. That's why we are choosing this type of materials, right? Okay, so plastic optical fiber, optical fiber is made up of a plastic, right? Okay, so plastic, it has the plastic core and a plastic cladding. For example, the core is made up of a polystyrene material, so whereas the cladding will be the methyl methacrylate, right? Okay, so next, for example, core will be the methyl methacrylate means the cladding will be the copolymer. So, we can choose the material by the way of refractive index of that material. That's why we are choosing this type of materials, right? So these are all the two different classification of fiber based on the materials. So we have two different types. One is glass optical fiber, another one is plastic fiber, right? So second classification will be based on number of modes. Okay. So based on mode, we have classified into single mode fiber and multi-mode fiber. So single mode fiber is nothing but it can allow only single mode of light propagation, right? So multi-mode fiber is nothing but it can allow more waveguides, right? So look at this diagram. So first one is single mode fiber. The second diagram indicates the multi-mode diagram, multi-mode fiber. So you can visibly check that. So core refractive index and the numerical aperture value is less than in multimode, less than compared to multimode fiber, right? So in multimode fiber, numerical aperture value is very high. In single mode fiber, the numerical aperture values will be less because it will allow only one mode of propagation, right? So it has very small diameter core, around 9 micrometer, right? So it carry only one mode, travels as a straight line, right? So it is used for speed data transmission over the long distance communication. So actually single mode fibers are used for transmit the light over the long distance communication. So it has very small dispersion and small numerical aperture and a large bandwidth, right? So these are only single mode fibers. It is used for the long distance communication and a very high speed. It has very high speed because it can carry only one mode of propagation, right? Okay. So next one is multi-mode fiber. It can carry more than two or more waves, right? So because of two or more waves are entering into the core, so it has core diameter very high compared to the single wood fiber, right? So it has very large diameter of core, so like 50 micrometers to 2.5 micrometer. It can carry many modes simultaneously. So it has high dispersion, large numerical aperture and a limited bandwidth. So it is used for short distance communications. Okay. So actually multimode fibers are used to transmit the light in short distance communication. Single mode fibers are used to transmit the light in long distance communication. Okay. So another classifications are explained in later video. In this video, I explained about the classification of optical fibers on the basis of mode of propagation and based on material. Thank you.